Hi, today I'm doing a Christmas special. I'm taking a break from coding and I'm gonna enjoy a warm cup of tea. By the way, if you haven't watched my spiderweb shooting tutorial, do check it out. But today I'm gonna review a project. It's something I made a very long time ago, in the year 2008, it says here in Roman numerals. So I was in high school when doing this. And I'm going to evaluate myself in the same way I evaluate my students nowadays. So let's see how it goes. So I'm here now with a mild cup of tea and the application on my desktop. Let's begin. So you can see here a bunch of characters down, and these are actually random generated. So they are procedurally generated, but properties like the color of the hair and the color of the clothes and type of clothes and style of hair and things like that is automatically generated here. I remember very much about this. And here you have some kind of instructions and who made this. So this game was made by myself and one of my colleagues, Cioty. Hello, Cioty, if you're watching this. And two of my teachers in high school, my computer science teacher and my physics teacher. And here we get some kind of instructions how to activate, deactivate noise, telling me that first I'm gonna make my character and that I'm gonna be able to talk to the other students to find out information. If you're gonna do all the lessons, so this is an educational game, you're gonna be learning things here. You're gonna be getting some bonuses and oh, and if I'm gonna be passing the tests, I have exams here, then if I'm gonna attempt the tests again, then all the questions are gonna be different, and there's also some place to have fun in this thing. So let's begin. I press start. And the first thing you see here is some settings, and you can create your own character here on the top left. You can change the style of the hair, you can change the color of the hair. Same goes for the eyes. So maybe we make him having green eyes, goes with the hair, and you can change the style of the eyes as well. And could add glasses, different types of glasses. Maybe I go without, and the pants, two styles, yeah. Coat also, and the shoe color and the skin tone. Okay, quite many different things here. And you can change from a boy to a girl. Oh, I think I lost all the settings here. Let's check also the girl character real quick. Okay, different kind of hairstyles. And okay, that looks nice. And then the dress, if it's longer or shorter, I mean the skirt. And okay, I think this is something fine. And by the way, these characters can be rotated here. So they kind of look 3D, but actually the way I did this is by drawing all the different angles. So it looks here like I can rotate every 45 degrees. It kind of snaps like that as I'm trying to rotate this character around. And this was definitely Flash CS3 because I see here some glow effects, some blur effects, and these filters were added after Adobe took Flash from Macromedia. So this is Adobe Flash CS3, I'm pretty sure about that. Wow, haven't seen this in some time. So let's continue. And now we are here. This is our character in the center walking here. And we have a bunch of other characters around, and we can pan a little bit on the screen here. And what you can do is essentially click somewhere in the screen, and the character is going to walk there. This is not really a 3D environment. It's just sorting the characters so that those that are higher on the y-axis here, they're gonna be behind. So eventually, if I'm going to go like that, I pass through the character somehow. Looks like there's also some kind of small avoidance implemented there. So I'm avoiding the character as I'm going close. Kind of interesting. And if you click one character, that character turns in your direction, and it tells you something like typewriter is the longest word that can be written with the letters from the top row of the keyboard. Well, I guess that's useful information. Let's see what she has to say. I remember there are 100 of these. Wow. Okay. A very old turtle was discovered somewhere in Cuba that lived at the time when Columbus discovered America. I almost couldn't read that, so 1 minus point here because that text was so much and I couldn't read all of it, and I think that high school students... Some kind of granite statue discovered in Romania. Very old stuff. So this text goes away way too quickly. Something about the rotation of the Earth and the Moon, and that the Moon is slowly going away from the Earth. The biggest eye in the world is that of the octopus with 40 or 50 centimeters in diameter. Okay, so basically that's what happens outside. It's just you walking around and clicking these guys. There's no fancy pathfinding or anything like that. It's just point and click to the direction, but a little bit of playing around with the size of the object to make it look kind of like 3D. Small avoidance that you're getting too close to something, then it's gonna somehow fix by not going exactly there. And the thing is, this is just some funny thing, but the whole software is about learning things, and you learn things inside the school. So this screen with these characters that I actually like pretty much, and they are my first procedurally generated thing ever, are only here, and I think that's kind of a waste. But let's go in the school next. Something happened here. The character stopped walking when hitting this thing. Let's try again. Okay, and inside the school, the laptop opens and nobody's in the classroom. I don't know why. I think I thought laptops were really cool back then. I didn't have a laptop back then. And I heard about something called one laptop per child, and that was something that somehow I thought that it's gonna be interesting to put inside this thing. So every student outside was holding this kind of computer there in one way or another. So inside the classroom, inside the school, you open this computer and you have something like a desktop here, like operating system. And I actually made this operating system myself. It's a small, simple operating system. You can drag folders around. They snap into place. The color of the desktop can change with this button here. And some clock there. I guess I wanted to show what time it is so that you don't spend too much time in this software, and it seems like it actually works. So so far so good. So these are mathematics, computer science, and physics lectures, and these are mathematics, computer science, and physics tests. So you will need to pass these tests. This is some amusement folder, and this is a bonus folder. I think the bonus is empty for now. This amusement has some things, but let's check them out a little bit later. I think they're probably very interesting, but I want to show you how the lessons work. So in mathematics, we have 2 lessons here, and as you hover over these files, you have 2 of them, and here at the bottom it says what it means. So this one is the distance between 2 points, and this is the middle of a segment. So let's see. Distance between 2 points. Okay, a lesson like this opens, and on the left it says the title, distance between 2 points, how to calculate the distance, and what is the formula. So this is the Euclidean distance formula for 2-dimensional space. And that these points are x and are a and b, and xa and xb are the x-axis and y-axis of this point, and ya and yb are that. And that the formula, this formula has the Pythagorean theorem as a basis. Now on the left here, you can actually underline things that you find interesting and that you want to memorize. And a really cool thing about this software is that every time you make a change like this, like if the power shuts down, then you can still see these highlights later when you restart. So every change that you do in this application, every test that you pass, every progress that happens is automatically saved. You don't need to save it yourself. It uses these like a local storage. I think it's something like Flash cookies or shared objects. I think they're called shared objects in Flash, but it's something that I haven't used for ages. I'm pretty sure it's shared objects. And here you can play around with these points. You can actually click on them, and you can see how these distances on the x, the differences on the x change, and the differences on the y change. I think this is pretty nice. Oh, it says here that I can also modify with the keyboard. So if I press now down on the keyboard, every time I press down, it moves the point downwards. The last point I clicked, I guess. So I can move them more precisely like this as well. But pressing these is actually horrible. It's like I'm trying to click, and unless I click exactly there on these few pixels, it doesn't work. And this is just horrible. Like you can't expect somebody to click exactly on that small point. Yeah, nowadays I would use maybe some different ways of doing this. Points should be at least larger, and maybe the click area should be bigger for it to be actually usable. And on the left you have some calculator. Let's see, does this work? Square root of 9. Yes, it's 3. Let's see, 1 divided by 3. Okay, multiplied by 3. Well, I would expect this to show 1, but it's fine. How can I break this? What happens if I press? So now I think I broke it. It has a 0.999999 dot. So basically, when I implemented this calculator, I wasn't that... Okay, now it doesn't fit anymore. Let's try plus 3. Error. Okay, so 2 point... Okay, now this point doesn't work anymore. Okay, I broke it, I think. Oh, now it works. And now another one doesn't appear. So maybe only when you get some kind of result there, then... No, I don't know. Somehow before I got it to... Yeah, after multiplication, then you can add a dot. Okay, my coding skills back then were horrible. This whole application, I remember it had about 50,000 lines of code. And that's not good. I mean, I was really proud of them, but I didn't know much about structuring code back then. And let's just say that you would want nowadays, I mean, all the time when building software, you want to have as little code as possible to do as much as possible. There was in history this Blaise Pascal, the physicist, had written a letter, and in his letter he apologized that he would have made it shorter, but unfortunately there was not enough time. So basically, he wrote it sloppy and used too many words more than necessary. And same thing goes for the coding as well. And yeah, so okay, let's say that we have learned this, and we might want to make some notes. This is a place in the right where you can write your notes if you want. But I don't know, I don't want to write any notes here. I remember all these things. So let's close it and open the second lesson. So this is about the middle of a segment. So same thing as previously, and also looks the same with the keyboard movement and some calculator here if I need to, I don't know, double check these calculations or something. So I just find out that the middle of this segment is found by averaging the sides, I mean the endpoints of the segment. Maybe this is the key information here. All right. So I know these lessons very well. I'm gonna go to my tests. So I open, okay, double click doesn't work. It works if I do it fast enough. I think that I had to implement the double click myself by starting a timer at the first click and then checking again at the second click how long time it took from one to the next. I think the double click support wasn't there in Flash back then, at least. I don't know if it is now. I haven't used it since maybe in the last 10 years. But anyway, I remember that I had to do that, and I think I programmed it so sloppy that the timer when I first clicked that is still running now, so that I didn't stop it. So basically, I think that now in the memory, I have a bunch of timers every time I clicked on each folder. One of the there's one timer for each, and they are still running. And even though it passed the double click threshold, I think I'm still using memory for those, so it's really sloppy things. But I don't have the source code. The source code was not on this disk, so I can't really check how I implemented these, but I do remember some vague details. Let's see the test. So, wow. Okay, so you need to get over 5 to pass this. This is from the distance between 2 points and the middle of a segment. And you can redo the test anytime you want, but every time you redo the test, questions are different. If you pass, you will have again, you will get more lessons and you will get a bonus. But you have to go outside the school for some reason. Yeah, I think you don't see those bonuses and whatever until you exit the school and come back. I think there was some reason I didn't know how to do it without that, but I don't remember exactly. So here it asks like the square distance between A and B. So we have A and B, and what is the square of a distance? So on Y, there is nothing. It's 8, 8. It's the same Y. So the only thing that matters here is actually the X. and the delta x is 2, so the square of 2 is 4. Here we have 3 points. Wow. The floor of the perimeter of this ABC triangle is okay. I think this is tough to do. I would have to calculate the distances between each of these points and then calculate the perimeter and then just input the floor, so the part before the decimals, but I'm not gonna do that. It takes too long and I don't have mental energy for this right now. I try to take it easy today, not work. So let's see the next one. I don't need to pass all of them. If these points are there, what is the square of the distance from C to M, where M is the middle of AB? Wow! Okay, so middle of AB is easy. It's 4.5 here and 3 here, because these are 0. But then we have 4.5, too hard. Let's try the last one. So B is 3 and 9, and if M is the middle of AB and M is 2 and 4, what is the sum of A's coordinates? So this is more easy. A is going to be 1 and minus 1. So here we have the delta on Y 5. So 4 minus 5 is minus 1. So A is 1 and minus 1, and the sum is going to be 0. And I passed, and I got 5 as a result. Great. So now for some reason I don't see the second test here, and I don't see the next lessons, and I don't see my bonus that I got, unless I go out and go back inside the school. So I'm gonna click back inside the school here. And now if I go to math, I have 2 more things. This one is the center of mass, and this one is perpendicular line segments. Wow. And the next test is going to be here. And just out of curiosity, let's open the first test again and see here the coordinates are different. So every time you open these, the questions change. I mean, they're the same questions, but the values here are different. And these are randomly generated pretty much. Okay, let's see the bonus. So the bonus here is, it's actually something I did in another project, maybe a couple of years before this one, and it teaches how to make origami shapes. So this is gonna be a lesson that teaches how to make the origami crane. And it's frame by frame animation of this crane model. I spent a lot of time doing these kind of drawings and playing around with what Flash could do. On the left I have information about what kind of paper should be. It should be a square, medium difficulty level, my first impression at the model. So this one got 5 stars. It's no wonder it's a classic. And here are some uses. It can be a toy, or it can be a decorative object. If decorative object, if you make it properly, like colored paper, preferably different color on the 2 sides. And on the right you get instructions for what you're seeing here, like the step that I'm repeating now. I can also go backwards to see these steps again. but in Romanian language it says there instructions how to do those things. Okay, so there it is. Okay, I think it's quite nice. So there are many here, and all of them are going to be this origami, different origami models. It says here a text in the, kind of faded. It says imagi ro, and ro because it's in Romanian language, but and imagi is like for imagine, I think. But also, if you read this opposite from in reverse, it says origami, which is basically the name of this art, the Japanese art of paper folding. So these are the kind of bonuses that you get there. Let's test also the computer science lessons. So we have here, oh boy, I don't know how to translate these. Well, palindrome is palindrome, but the other one is like mirrored, the mirrored number, like a number that you read in reverse. And this one here is the greatest common divider between two numbers. So this GCD, but they are written in Romanian language. So now I open this lesson. Okay, so information on the left, what is this mirrored thing? Like here you get the mirrored value of this one is this one. You just read the digits in reverse, and then the palindrome is something that is like this, that you read it the same way from both ways, and that these can be done also with strings, not just numbers. Like for example, these are some words that are palindromes in Romania, or this sentence if you neglect the spaces. By the way, if you click on any one of these things here, they will be removed. Yeah, and here this is C++ code for how to calculate the mirrored form of a number. So given an n value, we mirror it here, and then y is going to be the mirrored form. And then we also check here if it's equal to the original number, and if so, we say it's a palindrome, otherwise we say it's not a palindrome. Nice. And on the right, we have some visualization of the algorithm. So if I'm going to enter here a number, maybe 164, let's add a few more digits. So 16,452. And now I press enter, then I have the number there. And you can see here the algorithm, every time you press enter, something happens. So now you get the reminder from here when you divide by 10. So that's 2. And then you multiply y by 10 and add the reminder there. So basically y was 0 and now it just becomes 2. But then you divide x by 10, and in C language this means that you keep the floor of the value. It's converted into an integer. So basically you cut off the last digit essentially. And you repeat this. So now you get a new reminder. You multiply y by 10, so it's going to be 20, and then add plus 5, and going to be 25, and so on. It's basically a fast illustration of how you get that, and a small check at the end if this is a palindrome or not. I think this is really good. No problems like with the mathematics lessons where you really had to click those things. precisely, otherwise it would break. So precisely, otherwise precisely, otherwise it doesn't work. So here it's okay. A little bit issues with the border here, like I can't really tell the first digit here what it is and so on because of this inner shadow I'm using. Second lesson. The greatest common divider, and this is Euclid's algorithm. I remember this Euclid's algorithm. I think it was being taught everywhere. So the greatest common divider of 28 and 24 is 4, and I'm gonna enter here 24, 24 and 28. So now we have two numbers there and another remainder when we divide one by the other, and then some things change there. X becomes Y, Y becomes R, and so on. And in the end, this X value is going to hold. The result, I think. So this while loop repeats until this Y is 0. Okay, so that's it pretty much. And let's see the test for computer science. And the test here, the mirrored form of this number is 62. Introduce a number that is a palindrome. I have 0 here. I mean nothing here. It should work if I don't introduce anything. Maybe it warns me that it's empty, but it doesn't because I didn't answer anything to the other tests. Let's just leave it blank and see if it works. Enter two numbers with greatest common divider 5. Let's put 10 and 15. So 10 is 5 times 2 and 15 is 5 times 3. So their common divider is 5. Enter two numbers that are, I don't know how to translate this, but that they don't share any common factors. So maybe 10 and 21. Yes! I'm better at computer science than at mathematics, but I think that these things are mathematics just implemented on a computer. Okay, so closing this, and I passed it, but again I have to close this computer, go back into school. Okay, this opens again, and now I have access to the next two lessons, which will be check if a number is prime, and sum and product of the digits of a number. And more importantly, our bonus. So now we have also airplane. Okay, we have a model of an airplane here. Wow. This is not a normal airplane. It's a high level difficulty airplane. Okay. It's a complicated airplane. I don't remember how to make this airplane, but I think it's quite nice. Let's see if it is. So far it doesn't look much like a... well, maybe a bit. Okay. Okay, yeah, it is an airplane. I don't remember how to make it, but it's... Now I vaguely learned from clicking on this very quickly. Anyway, this was fun. Yeah, now physics. Physics is something I didn't do. All the physics lessons were done by my colleague, by Cioty here, and we just included them. So each of these lessons were separate files, and we could work on them independently after this operating system was made, and they could be included there. And we did this project as a team, so let's see what physics is like. First one, we have the light reflection, and then we have the planar mirror, like the flat mirror. So reflection of the light. I'm moving this thing around and wow, so much text. And actually that's a minus for me as well. There was so much text in that computer science lessons, and you could teach these with far less words than this. And I don't even know what these things mean. Like, it says what reflection is, and that it's the light coming back in the same medium after reaching a separation surface with another medium. The name of these rays are called incidental rays. I don't know. And these are reflected rays. If this surface would be irregular, then that's a diffused reflection. Oh boy. If something diffuses the light in all directions, it's a flat surface. It's like a, like, not glossy, but something that doesn't shine. I don't have good terminology, but anyway. And then the first law of reflection, and then the second law of reflection, and basically all this says is that this angle is the same. So every time I'm moving this angle is the same here and here. So not very complicated, but I wouldn't know how to say all of these things. I would need to read more. And complicated stuff like telling what happens. I don't know, something's parallel here. Yeah, complicated. And then the second one, the mirror. Okay, similar kind of application as before. We have the mirror there. These are really nice. I really like them. But this part here, oh no, it's like really bad. It's so much text, and like I try to read everything. A very flat surface, usually metallic, that reflects almost entirely the light is called a mirror, a planar, a flat mirror. The way in which these objects are formed can be deduced with the laws of reflection, so what we studied previously. It's sufficient to consider two rays of light coming from a source. They reach the surface of the mirror and are reflected according to the laws of reflection. These rays don't intersect. They're extending them. They do intersect in a point away from the mirror. Wow. So yeah, so after these reflect, and you see here, this angle is the same as this angle, and it goes like this. they don't intersect, but if you extend them like this, then they intersect on the other side of the mirror. And that's going to be where the point is. Interesting. Because these images are formed at the extension of these lines, this is called a virtual image. The distance from the point to the mirror and from the image to the mirror is equal. And the size of the image is equal to that of the object. The image is reversed from left to right. And these things you need to remember. Very, very simple things you need to remember, but the text here is quite hard. Okay, let's see the test. Okay, a ray of light touches the separation between two mediums under the angle of 25 degrees. What is the angle of reflection? It's 25 degrees. A person with a height of 194 is looking at itself in the planar flat mirror. What's the height of the formed image? It's the same. Knowing that the distance from the image to the mirror is 4, what's the distance from the object to the mirror? These are just the same numbers here that we have to enter again, I think. I hope. Let's see. Yes, this one was very easy. So again, this one is ending and I'm gonna close this, go back in the school, and now I have another test available and more lessons to study. Refraction, light refraction, and optic fiber. Let me see these. I'm curious how the application here looks like. So this is refraction. Okay. It's when the light passes in the other medium. And here, okay, we have a bug. No, it's not a bug. I think this when this value is small enough like this, then it doesn't let me move it down. I think that this is on purpose. Otherwise, it will do the reflection. But I wouldn't have done it like this. I would have actually shown the reflection and have a single application here. Okay, and this is very difficult. I don't spend time doing this now. So this is the way that things go, and there are many lessons. I don't remember how many exactly, but I think that there are at least 9 or 10 tests here, so the number of lessons is quite large. Maybe I'm gonna try to play this until the end later and see all the lessons, but let's check this amusement folder. So this amusement folder is actually something more interesting because these combine some kind of applications I built previously, and we just added them here to because they have an educational aspect to them, like this. Here it's a game called Computer Science Labyrinth. Or yeah, you have, wow, okay. some features here with teleportation. You move here by rotating the field. I remember making this game and it wasn't easy to do. But then I added these questions in it to make it educational, and I think it became worse. But you use the keyboard keys and you rotate, and then this character just falls down. So then you have question like, are these two numbers, do they share any common factors or not? And if they don't, I have to press yes. So yes. And now I'm going. So this rotating this labyrinth here makes me progress, and I have to reach this destination right here, and after I reach it there, the point goes down to the next level. Let's see how it goes. Is it a palindrome? No. Oh. Okay. Commands are pretty good, actually. Yes. The greatest common divider. Okay. Is palindrome only specific to numbers? No, there were some examples there with the strings as well. A mirrored form of the number, yes. Oh, no. Oh, I read it badly. I was too in a hurry, and now I have to do this again. Yes. I was too quickly pressing that. No, this is not a palindrome. Controls are pretty good. It's surprising. Yes. I remember making this, and it's just a matrix with ones and zeros, where we have these kind of walls there, and they are predefined, so the same levels are gonna be so 3, 4, 1, 2. Yeah, it's not. So the same levels appear all the time, and here the same questions appear all the time. There's nothing fancy going on, like in the tests where they change. 2 is the only even prime, yes. Okay, and now we are here, and I still have to align this point here to that location, so now it goes to level 2, and so on. Product of the digits is 6. No, it's 0. I guess I thought 0 is some tricky thing to include there. Okay, I'm not gonna go more in this one. But this second game now, it's Catch Me, but Ma is like the beginning of mathematics, so I think this, yeah, it's this, you have to catch the correct equations and ignore the wrong equations with the left and right keys on the keyboard. So I just moved this, and that one is false. Correct. Correct. False. So you leave it to fall if it's false. If you make a mistake, like if you forget to catch something, then it's a mistake. Or if you catch something wrong, it's a mistake. Then the mistakes are counted here. Okay. And this is now the plus here, so I think at some point minus comes, and then probably multiplication and addition and subtraction. This is not easy. Let's see if something else comes and then I stop. Okay, now it's minus there. Oh, I made a mistake. Yes, this is true. Okay, so now it's minus up here. This is good. Minus there. Probably others come, but I'm not gonna play this more. Oh, I made a mistake. Yeah, definitely not gonna play more. Starting to make mistakes already. But you got the point. And I think that this level here, yeah, the level there is just number of digits that the numbers have. So let's actually play this a little more. I'm curious if I'm asking people to do multiplication with so many digits. So I'm curious what happens after this division is there. Okay. Ah, it was wrong. Mm-hmm. Okay. Yes. No. Should have stopped playing. Okay, these are easy so far. You can tell that I'm struggling because I'm not talking anymore. Yeah. Okay, this is level 2, is it? Okay, one of the numbers has 2 digits. Okay. Ah. Ugh. Oi, what am I doing? This is very hard. I'm not in a mental state to be doing this right now. And it's getting faster. Okay. Ah, no. No. Yes. And now we have the division. Yeah, okay. As since I did this already, I'm going to, since I went so far, I'm going to go all the way to the end and see what score I get. Hope it doesn't say something like I need more studying. Ah! Was it good or bad? Okay. Yes! Haha. Oh no! Oh, this is too difficult. Okay. What? No, this is horrible. Haha. Okay. Oh, that was good. What? What does it mean? 1 triple equals 86? Okay. I think it just starts again. So I guess 86. Okay, then next up is going to be this Buffon needle. This is something interesting. It's a statistics kind of experiment. You estimate the value of pi by throwing a needle on this kind of surface area. And you have these lines that are as far apart as the needle is long. And if there is an intersection, then you count how many intersections you have. And you also count how many numbers of tries you do. So basically the point can be, the needle could be in a way that it doesn't intersect. So not all intersections, the intersections will be less or equal to the number of throws. But as you repeat this, if you calculate 2 times the number of throws by the number of intersections, you will eventually estimate pi in that way. And I remember implementing this, and I actually do that. So I put a line there, I rotate it, and I try to check for intersections, and if it is, I increase those numbers and so on. And you see this number is approaching approaching pi somehow. If I press enter, I can see with slow motion. Okay. Yeah, so good, nice. Then now it's no intersection. Intersection. Maybe no intersection. I didn't check if it increased, but it looked like, I don't know, but it's quite borderline case there. Hard to say because of this smoothing effect. This aliasing, or how you pronounce it. This is no intersection, clearly. Okay, releasing enter, and I can also experiment with 100 needles at the same time. So this was probably some idea to get the estimation to go faster, I mean, to go quicker. And interestingly, I'm going further away from pi. I don't know if this is a mistake or not, but it could be a mistake in my code. Or it might just be the way it estimates it, not very good unless you do a lot of estimation. But I think that it could be some mistake in the code as well. Maybe using this, like when you draw a line on the screen, then usually the computer fills in pixels on the side of the line to make it more straight. Otherwise you get that kind of zigzaggy artifact. So this effect, I think, might contribute to this, me checking if something overlaps something else. I don't know if I did this check by measuring, doing math and doing coordinate calculations, or if I did this with pixel values, like seeing if there's a pixel value that is black and red, has like a dark red, then that would be intersecting between this and the black pixel there. I really have no idea how I implemented this. But anyway, something works, and it's quite close to pi. 3.1 is already some approximation. Maybe if we run this longer, seems to go up again. So anyway, interesting thing to have. Now I close this, and I really don't know if this is still working in the background now, doing a lot of work or not. Now this one, oi, this is something, this is a game called Nim, and I don't remember anymore how it went exactly, but for some reason I'm showing it here on the chess board. And here you play against the computer, so there was also some kind of AI element here. Says here that it's a game from China and it's a two-player game, and you can take any number of pieces from a single column. And the player that can't take pieces anymore loses. So let's see how it goes. Okay, now these turned into pawns. Interesting. So it's my turn, I think. And I can take some number of pieces. Like maybe I take these 3 pieces. I think I can just press here. Okay, so I pressed there and then the computer took these 2. Now I'm gonna take again something. Okay, and now the computer took that one. Now I'm gonna take something again. Maybe I take this piece. Yeah, I lost. Now I take this one. I take this one. And I lost. The computer took the last one there. I don't have where to take pieces anymore. Okay. I don't remember everything here. How it really worked. I do remember it. Okay. So computer took something. I remember it has something to do with this XOR operator, this exclusive OR operator, and that you can actually figure out from any configuration what is the correct move to make. So computer, I think, might be playing perfectly. Oh, now I can win. So now I take this one and I win, yes. I don't remember how this worked. If somebody knows, let me know in the comments. I can figure it out also by researching on the internet or something, but I'm not gonna do that now. So I don't remember if the computer plays perfectly or if there's some randomness so that he can make some mistakes sometimes. Also, the player who is in the beginning is important because if you're in a configuration where any move where you cannot trap the other player by making the correct move, that player is going to make the correct. You're gonna put the table in a suboptimal state, and then the other player is gonna make the optimal move. So it could be that I just played perfectly now by mistake, and I mean I did a little bit of thinking, but I don't remember anymore the rules and the strategy to win. So anyway, interesting game. I do think that you XOR the values here and they need to be somehow, but I don't remember and I won't think about it anymore. Yeah, I used to know how to play this and beat anybody, just making some small calculations in your head. If you're interested to know a game where you can beat pretty much anybody by doing a little bit of math, and others are thinking, how is this possible? Again, with any kind of configuration here, so they can have as many pieces as you want. And I think originally this has been with stones or sticks or something, but yeah, I lost. I am pretty sure the computer is knowing what it's doing. Yeah, but I made it here with the chessboard for some reason, and I guess you can use the chessboard as well. And then last but not least, there is the Hanoi Towers. And I think everybody knows these. It says move the pieces somewhere else, and you can only move one smaller piece on top of a bigger piece. So I don't think it matters where we are moving these as long as it is something somewhere else. And we can have more pieces here, let's say 6. I have a feeling I did way too much. Um, yeah, quite many clicks to do in this one. But nice addition. So now we have this one here, and all of these need to be back here somehow. So now I'm thinking this piece at the bottom, second from the bottom, needs to be here. That means that this second piece has to be here and this piece has to be here. So somehow simulating the moves in my head. And now this one can go here. So now we just have these 1, 2, 3, 4 pieces that need to be here. Right. Okay, great. So this is it, pretty much. Oh, let's see the third bonus from the physics test. Okay, this is a boat, and it's with a rectangle sheet of paper. Yeah. Okay. So there are a bunch of other things here. Maybe I'm gonna play a little bit around with them. I have some time. So I'm gonna play with these, try to do more lessons, see how it looks like in the end, and make some conclusion about this software. But I probably will speed up this part. Let's see. Okay, I think I had enough, but you can see here mathematics, computer science, physics. I did about half of each of these. So let's go back inside and see all the bonuses that were enabled. So inside each of these folders, we have now more lessons. So now we have, wow, also trigonometry here, like sine, cosine. Okay, how do I... It says to move the green point, but... Oh, this is blue, not green. This is the green point. this axis here doesn't have a label for what is the value over here. It should be 1 and -1. So that is missing. But these are not bad illustrations otherwise. These are really good. So this is now teaching us the sign, and that the sign is that the length of that red line there. It's just missing information about 1 and -1 here, and 0 and pi here, or 2 pi here. This is pi divided by 2. So I would just put more numbers, and definitely -1 and 1 should be on the chart, not mentioned somewhere on the left there. And the cosine, I guess it's the same, but yeah, but a little bit different there. Okay. Interesting that here, like, this label is... No, never mind. I think these are placed here just by me drawing them there, so it's nothing very systematic, and a lot of spaghetti code in this stuff. Okay, and then computer science, the last lectures here are minimum and maximum in an array, checking if a vector is a palindrome. Wow, interesting. So minimum and maximum in a vector. So it does include vectors now, and that's a little bit more complicated, I think. But I think actually the process of dividing the number by 10 and getting the digits one by one is even more complicated than traversing an array like this. So we already had previously something, I already saw something like this before, but with digits. Yeah, I think it's just becoming not easier, but all over the place. The concept of arrays is more complicated, so yeah. I guess we will also get matrices later and so on, but I won't have time to look in that. And physics lessons, refraction, fiber optics. What is this? Aha. It's showing how the light goes in this fiber optic. Interesting. Cable and convergent mirror. Wow. Convergent mirror. Where is the mirror? And divergent mirror. I think I can visualize it, but okay. So this sign here is for divergent mirror, and convergent mirror probably had opposite these arrows here. Yeah, so complicated symbols. I would just have made this one, drawn it kind of like this shape, and this one would have been drawn in this shape, but I kind of understand why it is like this, somehow to introduce these symbols that you might use when you solve equations or whatever. Okay, but interesting and more complicated functions here. I actually didn't know how to solve the last test from here, and there are more. So this is about halfway how it looks like, and nothing different happens here. These are static, but in the bonus start to have more things here, like a ball. This is actually the water bomb model in English. It's something that you can fill with water and throw. It's funny. This is, I call this the little devil, but I think that this is actually looks kind of like a bunny also. I don't know. Anyway, you have to blow in it here to open up like this. It's similar to the water bomb in that case. And then you have a frog. Another airplane. Okay, this is much easier model. I think everybody knows this model. And another boat. Wow. Very geometric boat. Okay, interesting. I don't remember this boat, but I wasn't impressed. Okay, so this is it. In conclusion, it's really hard to say this, but project has a lot of potential, I think. It was all over the place. It's like filled with different items, different past projects, just to somehow show off and impress. But a lot of work went into these kind of characters here, and they were not used at all. I mean, they were just used for this kind of, did you know that the wolf has the highest body temperature among mammals with 42 degrees Celsius. So a lot of work went into these guys, and only thing that they do is talk a little bit to each other here, and most of the things happen indoors. And now my perspective is completely opposite, is that you should use computer as little as possible, because you will end up using it in your work pretty much whatever you do nowadays. So might as well go outside as much as possible, and maybe don't carry it along with you like that. So anyway, a lot of missed potential here with what you could have done with these other students. In the last 4,000 years, no new animal was domesticated. Okay, great. Then inside the school, that operating system and everything there, it's quite nice looking, and the things behave okay. A little bit buggy. Biggest concern is that way too much text. So trying to visualize things is quite good. And it's helpful sometimes. Like here, this kind of center of mass of the points is very nicely illustrated, and these kind of situations where you can drag these and they also snap into place so that you can actually have parallel lines, otherwise it would be difficult. That's quite good, I think. I would put coordinates next to the actual points themselves. This is a little bit difficult, like to look at here, and also impossible to drag these. So I think that I have very good mouse control, and I'm having difficulties, and many people will have difficulties with this. And if this is aimed at school pupils, then they won't have so much patience to do this like I have now. They will just want to do something else. And yeah, this kind of control is just horrible. Many things that are really good here, I think, like highlighting this is very useful. And then next time you open that, you do get all those highlights that you have made in the past. So these are really useful, but all the text here is way too much in my opinion. So it would have been enough to just put the highlights there as text, and not so many details there about what is happening. This calculator, I didn't find it useful at all. I actually used Windows calculator to do some tests quickly just to get more bonus items there. And basically I cheated in the test. Maybe it would have been good to have the calculator in the test, because I don't know how important it is for people to do mental math nowadays when you have computers for it. Of course, it's very important, I think, because the only way you get better at logic and at thinking is by practicing it, and doing math is quite useful for that. So maybe having calculator here in the first place is not a good idea, especially if it's buggy like this one. Okay, so overall, I think that some things here are, again, really good, like highlighting this and the fact that it stays like that, like auto-saving feature. I don't think that there were auto-saving features in the software back then. There might have been some of them, but I often remember things crashing, especially Flash crashing, and then opening it and nothing is saved and I have to start over again. I didn't have the habit of saving everything I do, and every time I saved, it would have taken maybe half a minute, because what I said previously, code was a mess, it was a lot of it. Graphics were quite many, drawing these characters in all these different angles. And I didn't even mention that for each angle you have the walk cycle animation here. So a lot of frame by frame animations. Largest mountain in the solar system is Olympus Mons, and it's on planet Mars. Okay, so one more thing that I like, these tests. So the fact that the tests are always getting new numbers here. So the 6233 and then changing with 2732. The values there change all the time, and they don't just change randomly. They change in a way that it's actually making things easy to compute. So the number of possible values or pairs of values or some kind of logic is there, so that you don't end up calculating things with many decimals, and then you have problems like how many decimals do I enter here, and then the calculator on your machine or in your hand might show some decimals, and then another one maybe shows less decimals. Is it a real number or whatever? So here it looks like I did a little bit of extra thinking there. So auto grading here for the tests, done with a little bit of thought, and I think that this is really nice. And I don't know if there were things back then that did this, but now there are like many ways of automatically grading, and also randomizing some questions or randomizing some values, I think, is very common nowadays. But I thought it was a good idea then, and I didn't see it at that point anywhere else, so I considered it a unique thing. And I have to evaluate this at the time as it was made. So it's not fair to evaluate it compared to what we have today. Like, instead of these kind of hand-drawn characters, you can have maybe 3D models and whatever you could have had already back then, but maybe not in Flash. Or maybe you could have, I don't know. I didn't know all the features, but I'm quite sure you would have struggled to have 3D models back then. And this has its own unique thing, like how many 2D characters can be rotated in different angles nowadays. It's something that it's kind of 2D animation, it's its own thing, and not this kind of not included in so many games where your character is moving all around. So I think there were quite many nice ideas here, but objectives are really unclear. Tests are getting easier, at least to what I've seen now. The physics tests, they get harder, and the questions are more difficult, and you need to know more formulas. So I think that Cioty did a good thing there with that, but the others, they just seem a little bit out of order or something like that. Yeah, but if somebody would do something like this now, then I would even compare this to a master thesis project. Not the thesis itself. Thesis is totally different thing, but a project that the master student would do. Educational software like this, it's actually that level, but the code quality is horrible. Like if this is really 50,000 lines that I remember, and I think it is like that, it's horrible. This doesn't need that many lines of code. It would work just fine with 2000 max for everything here, including this kind of custom operating system and the characters that are animated. I think I really had no knowledge of how to structure code, and I might have even had issues with loops. In Flash, we had this event-driven development, and there was this um, frames that are updating. So those were kind of like loops with a given frame rate, but you only need to write if conditionals inside of those because the iteration loop is going to the loop is going to come automatically somehow. It's hard to explain, but anyway, my programming skills were not very good back then, but I just had a lot of patience and perseverance, and I wanted to get something done. And it was how I learned and how I got interested in these things. So anyway, code is horrible. I don't see it now, but I remember it. And I remember that I tried looking at it a month after, while I still had the sources. My code for this seems to be disappeared. My it was on a hard disk, but that hard disk broke down, and then I didn't have access to it anymore. So now I don't have the code anymore, but I do remember it was really horrible. So from that point of view, this would need complete refactoring. So it doesn't pass as a master thesis project. The ideas are really nice. They need polishing and they need fixing some things there, like the bugs in the calculator and those visualizations. They need to be more easily usable, and text needs to be less, and the important things need to be emphasized if you really want to have an application that people don't close after you open it initially. So refactoring and a little bit of redesign there, that could be the level of a master student project. I think so. And it would be in the field of education or something like that. So making some application that teaches you something and tries to teach it in a fun and interactive way. Now, these parts here would really need to be used more. I don't know exactly how, but these characters need to be somewhere. Even if all there is just some random character inside when you're reading some lesson here, like checking if a vector is palindrome, just show the character there talking and telling you, hey, did you know that palindromes work for vectors as well? Arrays as well. So those characters need to be used more if you want to make something more entertaining. So this kind of level of text is just way too much, and I would have used the characters more, less text, and they would be talking to you, not just this kind of boring reading the text from somewhere. It's a waste, a lot of work, and it was wasted. I do remember that I used the characters in some other applications also, so they weren't just for this project, but still, it's a waste. I've used these way too little, and it took me forever to learn to draw all these things with just my mouse, and yeah. So a lost potential there, I think so. Okay, and then could this become into a master thesis topic? I think that yes. I think that especially if you think about the project back then, trying to find other software that do things like this, like automatically saving the state, automatically generating questions, and cite those, make relevant citations. Look a little bit more in how educational software is around that time. And even today, maybe, I don't know. I think it could be still a master thesis topic in education field in computer science. So how to teach computer science and related things, mathematics, physics, they are very much related here. Yes, I don't know if the bonus here is so intriguing, like more bonuses are going to come if you do more lessons, that's great. But they are only interested if you're interested in paper folding, maybe putting some of these other things to appear when you pass a test could be more interesting, and then removing some stuff like the questions here, I think they ruin the experience of this. So I would just have this as a labyrinth game that you just move around and have to find a destination as fast as possible. Maybe you get scores with how quickly you get there. This game is tough enough as it is. It's not easy to solve a maze when everything is spinning around. So with these questions, it's just like pissing off. And then you have to restart if you make a mistake, and that's like not so nice. So I would have kept these without the questions part and just give them as fun things that you can learn, that you can practice your logic or your problem solving skills or whatever in addition to these origami. So now this amusement is here in the beginning, and after you see these and after you play with these, then the lessons are just boring. If you're not interested in paper folding or what else can be made from paper, then the motivation is not enough. You would need some more motivations, get something more out of the lessons, I think. Because again, this origami is tailored only at some specific group of people that are interested in these things, and not everybody is. Anyway, so that's it. I really liked looking at this. I don't know if this gave you guys any ideas. Let me know in the comments what you thought about this video. I really lost a lot of my projects, like I had few before this one. This kind of origami thing used to be its own project. I don't have the source for that anymore. I had a project for my bachelor studies that was quite interesting, but I lost it. I'm gonna ask my computer science supervisor in Romania in my bachelor studies to see if she has my code from that one. It was some airplane game that you move with your head in front of the camera, some kind of face detection thing there. Let me know if you would be interested to see some of my past projects like that and tell how they're made. Now, this Flash is not any more popular nowadays. It's actually not supported in browsers since 2020, I think. But you can implement all of these things in new technologies with no problem nowadays. Like this could be easily done in HTML canvas and JavaScript. So yeah. Anyway, this was more of a gift to myself, but if you found it interesting, let me know in the comments and maybe I can make something like this again someday. See you guys.